So in the last video, we talked about RBF, or replaced by fee, which is a feature used by senders of transactions when a transaction gets stuck. We essentially indicate that we want a transaction to be BIP125 replaceable by adding a sequence number to a raw transaction, and that allows us to update the transaction and increase the transaction fee, making it more likely that the transaction will be included in a future block. And so that was from the sender's perspective. And in this video, we're going to talk about making transactions that are stuck free from a recipient's perspective. And so from the recipient's perspective, they can clear a transaction by using what's called child pays for parent, or CPFP. And basically the idea is that the recipient has a transaction that hasn't been confirmed in a block and they want to spend. So they basically include that unconfirmed transaction as a new transaction, and they pay a high enough transaction fee to encourage miners to include both the original transaction and the new transaction, or the child, in a block. And as a result of this, the parent and child transactions, they clear at the same time, basically. And so this isn't I guess a protocol feature, but it's more of an incentivization scheme that allows miners to select transactions, and it doesn't have as many of the same powers as RBF, but it's still a useful feature nonetheless. So I've got this diagram up on Coinbase's blog about child pays for parent, which is definitely worth a read, and I'll include in the video notes. But what it shows essentially is two transactions, transaction 1 and transaction 2. Transaction 1 was funded with an input of 5 BTC, and 2 of those Bitcoins were sent to the user 1 address, and the change was used to fund another transaction, which I'll go into in a second. And then the second transaction similarly was funded with 2 Bitcoins as input and has 2 outputs, one that's being used in a child transaction, and one that has been sent to a different address. So basically what happens here is that when let's picture these 2 transactions as being stuck. And so when a user sends the 2 Bitcoins to another address, what typically happens is a change address gets generated, and change comes back to that transaction, basically. So similar to if you was to pay for a coffee or something that cost $5 and you paid with a $10 note, then you'd receive $5 back in change. And this is a similar concept with transactions. And so because this transaction is unconfirmed, the receiver of the transaction would need to basically find the unconfirmed transaction from transaction 1 or 2, predominantly doing this through methods that we've seen before. So getting the transaction ID as well as the vector output, or the index number for that output, and basically using it to create a new transaction, or creating a new raw transaction with those transactions as inputs to a new transaction. And then to ensure that the transaction goes through, it's recommended to increase the fee as well. And so what would happen is both transaction 1 and transaction 2 become unstuck, as well as being able to use transaction 3 in a new transaction. I hope that makes sense. It can be a little bit confusing following back and forth between transactions, but in essence, you just use the UTXOs, or the unspent unconfirmed transaction, as inputs for a new transaction, increasing the fee, and it will hopefully, there's no absolute guarantees, but it will hopefully incentivize miners to include the transaction in a new block. So you can take advantage of child pays for parent incentives to free up funds that have been sent to you but have not been confirmed. You just need to use the unconfirmed transaction as UTXOs. So essentially these outputs that I'm referring to here, output 1 and output 0. And just use the unconfirmed transaction as UTXOs and pay a higher than average transaction fee if you want to ensure that it gets included in the block. And so this is, I guess the way we want to think about this is that it's mainly useful for funds to get funds unstuck when you're a recipient of a transaction and the sender hasn't maybe gone through the process of trying to get the funds unstuck themselves. And so it doesn't have as many, I guess, powerful features as replaced by a fee, but it's still an alternative way to exert control over a transaction after it's been placed into the mempool and before it's been confirmed in a block. So that's it for CBFP, or child pays for parent. And in the next video, we're going to talk about what we're going to talk about in our next video. I think there's only a few more videos that I'm going to record left. The next sort of set of videos will be talking about expanding Bitcoin transactions, so sending transactions with a multi-sig. So this is sending a transaction where multiple private keys are needed to unlock the transaction. So we'll be talking about that in later videos. So I hope that made sense. If you have any questions, please leave them in the comment section, and I will see you in the next one. Peace.